How do solar flares affect our ozone layer? Excellent question. Now, atmospheric scientist Charles Jackman and a team of researchers from NASA's Goddard Space Flight Center and Hampton University in Virginia recognized a rare opportunity to gather proof that solar storms destroy ozone. They already knew that when protons bombarded the upper atmosphere that they break up molecules of gases like nitrogen and water vapor. Once freed, these products readily react with ozone molecules and reduce the ozone layer. So, Jackman and his colleagues recalled specific Northern Hemisphere atmospheric data from NASA and NOAA satellites that continuously monitor the composition of gases and molecules that surround our planet. Their findings, published in the August 2001 issue of Geophysical Research Letters, show that less than 1% of total atmospheric ozone in the northern hemisphere can be quickly reduced by one of these events. It is an indication of the power of the sun to actually affect the atmosphere in a sudden, cataclysmic way. Now, while the results do not show a significant impact on human health, especially considering that most of the ozone loss documented in this study occurs over the northern polar region, they are important scientifically. The study gives detailed and quantified knowledge of how a solar storm affects upper level ozone. As scientists race to better understand humankind's role in ozone loss, they must first be able to tease out the natural causes. A lot of impacts on ozone, like those caused by humans, are very subtle and happen over long periods of time. But when these solar proton events occur, you can see immediately a change in the atmosphere. Jackman explains that ultraviolet radiation from the sun continuously strikes the upper atmosphere. These harmful ultraviolet rays would make life on Earth impossible if it weren't for the ozone layer that absorbs this radiation. Ozone forms when three atoms of oxygen bind together to create a single molecule, O3. But when ozone absorbs ultraviolet radiation, the molecules split apart into a single free oxygen atom and an oxygen molecule of two tightly bound oxygen atoms, O2. O2 is the oxygen that we breathe, and it makes up about 21% of the Earth's air.